Today we'll be learning what's called hypothesis testing. And hypothesis, I'm sure you already know what it is. It's basically an educated guess that you make about a population. In statistics, usually it's about the population. And you test the hypothesis, whether that is right or whether it should be adjusted. Okay, so there's the hypothesis that you start with. It's called the null hypothesis. And this is something that we accept. So for example, let's say that we accept that the mean height of men in the world is 175 centimeters. Okay, this would be the null hypothesis. This is what we believe in right now. And then to test if we are actually believing the right thing, we use what's called an alternate hypothesis. Okay, and let's say that if you want to prove that the mean height is actually taller than 175, then you would make the alternate hypothesis that the mean is greater than 175. Or if you want to prove that the mean is shorter than 175, then you would make the alternate hypothesis that the mean is less than 175. Okay, so depending on what your position is, if you want to prove that it's greater or if it's less, these would be your alternate hypothesis. And if you test this and it turns out that one of these assumptions, when you test one of these assumptions, it could, I don't want to say prove, but it could show that the null hypothesis is not correct. Okay, so if it shows that the null hypothesis is not correct, then we reject the null hypothesis. Okay, so let's just work through a few examples on how to do this. Remember that when we're taking statistics, there's the big population. Okay, so this one is all the men in the world, right? Population. And we're taking the height. And we're assuming that the mean height is 175 centimeters. And when we got this hypothesis, we didn't just measure the height of everyone in the world. Right? We pick a certain sample inside the population and measure their height to get our null hypothesis. Okay, and we're doing the same thing when we are testing our hypothesis. We are picking a sample inside the population and determining if it lines up with our null hypothesis. And because we're not taking the whole population, the data that we gather for our alternate hypothesis, so the data we gather here, might not exactly be the same as our null hypothesis. But that shouldn't mean that we should reject the null hypothesis. Okay, because when we start off, how we got the null hypothesis is we didn't measure the height of everyone in the population. And also when we are taking the alternate hypothesis, we're not measuring the height of everyone in the population. So of course there's going to be some difference between these two data sets. There's going to be some difference. So we're not expecting them to be exactly the same, but we want them to be approximately the same. Okay, and this approximation is called the level of significance. And this is usually notated as alpha. Okay, and we use different percentages for alpha depending on the situation. We'll use 5% in this case. What does this mean? Okay, so when we say that the level of significance or that the alpha is 5%, we're saying that if the data we gather here is within 5% of the data we gathered here, they are not exactly the same, but if they're within 5%, or if there's at least a 5% chance that they are equal, then we accept that the null hypothesis is true. Okay, so they don't need to be exactly the same, but they need to be within 5% of each other. Okay, so that's what the level of significance is. Now, how we test if the data is within 5% of each other is we use something called the p-value. I'm throwing a lot of terminology right now. I'll work through an example towards the end, so I'm hoping that that would clear things up. Basically, what we do is we get a p-value for our alternate hypothesis, and we see if it is within 5%. Or I shouldn't say within. If it is less than 5%, if our p-value is less than 5%, so the p here stands for probability. Okay, if the p is less than 5%, it means that the probability that these two data sets line up is extremely low. So we reject the null hypothesis if p is less than 5%. If p is greater than 5%, is greater than or equal to 5%, then we don't reject. We don't reject the null hypothesis. Okay, so let's work through an example here to clear things up. And basically, the way you get the p-value is through a normal distribution. So let's say that our null hypothesis is that the IQ level of the mean population is 100. IQ. And let's say that you took 20 IQ tests. And you averaged the scores for those 20 IQ tests, and you got an average of 110. Okay, and now you want to see if, so your alternate hypothesis is that you have an IQ that is greater than the average. Okay, and I'm going to give you some more information. The standard deviation for the original IQ test scores was 15. Okay, so now you want to find the p-value for this score right here, 110. Your IQ score of 110. Okay, so because this is an average of 20. Is an average of 20 IQ tests. We're using the central limit theorem, and if you remember that, the mean of the average was the same thing as the original mean, and the standard deviation of the average equal to the original standard deviation divided by the square root of n. Right? In this case, the mean is 100. Standard deviation is 15 divided by, you took 20 IQ tests, right? So the n would be 20. 15 divided by square root of 20. Do that on a calculator real quick. It's going to be 3.35. Okay. And now you're using the z-score for this one. Okay, so if you find a z-score, remember, I'm writing the formula first. Okay, if you find the z-score, then you can find the probability, right? The probability that your IQ is 110. So that would be 110 minus 100 divided by we're using this standard deviation here, 3.35. That is going to equal 10 over 3.35, which is approximately 2.98. So if you remember, for the z-score or the standard normal distribution, the mean is 0. 2.98 is somewhere over here, right? 2.98 is somewhere around there. And let's look at the z-score table. 2 is right here. 2.98, let's, it's actually closer to 3.0 than it is to 2.9. So let's do 3.0. 3.0 is going to be 0.999. Okay, so that means that the area here is 0.999. But if you look at our alternate hypothesis, we are testing whether the mean is greater than the average mean. So we have to look at the opposite side here, the greater than part. So this part is going to be 0.001. Or if you change that to percent, it's going to be 0.1%. Right? And this is our p-value. This is our p-value, and if you see that our p-value is much smaller than 5% here. Okay, we're using 5% as the level of significance for this problem. This is much less than 5%. So this means that this happening, you getting an average IQ of 110 after taking 20 IQ tests, is extremely low if in fact you are average IQ. Right? So this would then reject the null hypothesis saying that you are average IQ, and you'll have to accept this alternate hypothesis, which is saying that you are actually greater than 100, or your IQ has to be above average. So your IQ is above average. Now, notice that if you got a 110 in one of the IQ tests, right? So we're not using 20 here. If you got 110 in one of the IQ tests, then your z-score would be 110 minus 100 divided by 15, right? We're using this standard deviation because we're not looking at the average, we're just looking at 1. And if you do that, you're going to get 0.667. Okay, 0.667. And if you look at the table, z-score table for that one, 0.7, right? 0.7, 758, 0.758. 0.758, or we're using at the greater than part, so it's the other part from there. So, oops, let me just roughly draw the graph here. This part is 0.758, so to get to the greater than part, like we did down here, we'll have to subtract that from 1. You'll get 0.242, or 24.2%. So if you just took one IQ score of 110, that is not going to reject your null hypothesis. Okay, and this makes sense because even though your average is still 100, you could do well on one IQ test. You could get above average score on one IQ test. Doing well on one IQ test is not enough to reject the null hypothesis. But the reason that we could reject the null hypothesis down here, was because that was your average of 20 IQ tests, which means it more accurately reflects your actual capacity in IQ tests. Okay, so depending on the number of tests that you're taking and depending on whether you're taking the average or individual scores, it's going to affect your hypothesis testing.